new section is entitled Vertical Angles. Vertical angles. Whenever two lines or line segments are formed, they make two pairs of vertical angles. Another name for vertical angles are called opposite angles. For example, this angle and this angle are vertical. This angle here and this angle here are vertical or opposite. Adjacent means next to. This angle here is next to that angle there. Those are not vertical angles. This angle and the top angle, they're vertical. They're opposite one another. Just go across and you get the other one. You have to cross the point of intersection. This angle here and this angle here are vertical. So angle 1, 2, 3, and 4. Angle 1 and angle 3 and angle 2 and angle 4 are vertical. 1 and 3 are vertical, 2 and 4 are vertical. A and B are vertical, C and D are vertical. Opposite angles are vertical, are called vertical angles, also called opposite angles. Now, I'm going to make an even bigger conjecture. I'm going to claim that vertical angles are equal. Now remember, this big angle is 180 degrees. So let me put a second line. So remember, the whole angle is 180 that I just drew. If this angle is x, well then this piece is what you add to x to get to 180. Well, we want 180. When we add these, we want 180. But somehow we want to get rid of the x. Because right now, if you add these, you get 180 plus x. So what you should do is take away x. Now, when you add these two, you get 180. If one angle is x, then the other angle is 180 minus x. Okay. Now, let's concentrate on this line. Oops. Let's concentrate on that line. This line, this angle from the center is 180 degrees. Well, if we call this 180 minus x, whatever you add on in the other piece should add up to 180. Well, I mean, it's already on the board, but if you have 180 minus x, what do you add on to get to 180? Well, you want the 180, you just don't want the minus x. Well, add x back. That is, this angle is x. Okay, let's do this one more time. Let us again concentrate on that original line. This angle is 180 degrees. This whole angle is 180. We're calling this portion x. So what's the value of the other half, the other piece that makes the sum of 180? The answer, like before, was 180 minus x. Now, just because I drew on this so much, I'm going to draw it again and just put in the values. Make sure I'm putting in the same values as that other picture to the left. And you notice something. Not only are these two angles I just highlighted, not only are they opposite, but they equal one another. They both equal x. Likewise, this angle and this angle, they're opposite. That is, they're vertical, and they're equal. So it's not because me or your teacher says opposite angles or vertical angles are equal. Never accept anything that your teacher tells you, that I tell you. It has to be proven to you. Vertical angles are, in fact, equal to one another. Okay, so question is, what can we do with such a thing? What can we do with such a thing? So, suppose we are given this, angle 1, angle 2, angle 3, and angle 4. And you are given that angle 1 is 103 degrees, 41 minutes. And you are asked to find the other three angles, angle 2, angle 3, and angle 4. The first thing you should realize is that angle 1 and 3 are equal. The angle, because they're opposite. The angle, or vertical. So angle 3 is that amount. Now we have to find 2 and 4. In fact, we just have to find one of them, because they're opposite angles, they're vertical angles. If you know what 2 is, then you know 4. Well, angle 1 plus angle 2 add up to 180. You have 103 degrees, 41 minutes. You want to add something to it, so you get 180 degrees and 0 minutes. What do you add to the 41 minutes to get no minutes? The answer is 19 minutes, because that sum is 60 minutes, which is just 1 degree. Now this adds up to 104. Well, let's do it differently. 1 plus 3 is 4. You want 0 or 10. 4 plus 6 gives you 10. Carry the 1. 1 plus 0 is 1. Add 7 more, get the 8. And this column already adds up to 1. So the answer is 76 degrees, 19 minutes. Now you were probably taught that addition and subtraction, they're interchangeable. If you prefer, you could have done 180 degrees minus 103 degrees, 41 minutes. Well, you have 0 minutes there. Can't possibly take away 41 minutes. So you have to borrow from the degrees. You don't have any single degrees or unit degrees, 1 degrees, so you borrow from the tens. Make that 7 and add 10 degrees there. Of course, when you borrow 1 from the 10 degrees position, that converts to, in the 1's position, 10 degrees. When you borrow a 1 from here, you borrowed 10 degrees. I mean, after all, if you have 70 degrees and now 80 degrees, now you have 70 degrees, well, you took away 10 degrees. So you have to add it back. Add it back to the 1's position. It becomes 70 degrees, 10 degrees. This is 7 degrees, and that's 10 degrees. All right, so now you have to borrow a degree, 1 degree. Do you make this 10? Absolutely not. Why do I say 10? Because there's always a 0 there. You have 0 degrees, and you just add 1. But that doesn't make it, because this is 10 minutes. That doesn't equal the 1 degree you borrowed. You have to make it 60 minutes. 1 degree becomes 60 minutes. And if you don't know what 60 minus 41 is, fine, borrow. 5 and 10. 10 minus 1, 5 minus 4. That's how many minutes you have. Now, degrees. 9 minus 3 is 6 degrees. 7 minus 0 is 7. 1 minus 1 is 0. Same answer as I got before. 76 degrees, 19 minutes. Oops. 76 degrees, 19 minutes. Opposite angles are equal, and didn't stress it when I said it the 1 or 2 times before, but adjacent angles are supplementary. They add up to 180 degrees. This adds up to 180, and angle 1 and angle 2 are next to one another. They add up to 180. So if you have something like angle 3 is equal to 2x plus 10, and angle 1 is equal to 4x minus 6, and you're asked to find, so this is given, and you're being asked to find angle 2. You're being asked to find angle 2. So you know that 1 and 3 are equal, and 1 plus 2 is 180 degrees. If you knew where 1 equals, for the record, 3 plus 2 is also 180 degrees. If you knew where 1 or 3 were, like say 1 was 110 degrees, you would know to add 70 for the sum to be 180. You would know angle 2 is 70. But you don't know angle 1 yet. You don't know angle 3. But you know what? You know they're equal. 2x plus 10 is 4x minus 6. The right-hand side of the equal sign has 4 x's. The left side has 2 x's. So I'm going to bring all the x's to the right side, which means I'm bringing the numbers to the left. And clearly that second line is equal. They read the same. They look the same. Negative 2x plus 6 equals negative 2x plus 6. So the right side is 16. The left side, the 6's cancel. 4x minus 2x is 2x. 2x is 16. Now, before I jump on finding out what x is, I don't really need to know what x is. I could get by knowing what 2x or 4x is. Well, 2x. Angle 3 is 2x, 16, plus 10. Angle 3 is 26 degrees. But angle 3 equals angle 1. If you want to verify it for angle 1, you need to know what 4x is. Well, if you know what 2x is, it's 16. Double it. 2 times 2x is 4x. 2 times 16 is 32. So 4x is 32. You take away 6, you get 26 degrees. So yes, angle 1 is also 26 degrees. All right, so if you want to know what angle 3 is, what angle 2 is. Angle 2 plus angle 1, which is 26, it should add up to 180. 4 plus 6 gives you the 0. Carry the 1. 1 plus 2 is 3. But you want 8. Okay, add 5. Now you have the 8. And if you want a 1, add a 1. Because we didn't have any other number in that column. So the answer is angle 2 is 156 degrees. The two angles should add up to 180. that doesn't mean you have to do subtraction. Okay. Suppose you have this picture. And it's labeled A, B, C, D, and E. And you are given some information. You are given that angle ACB is congruent to angle A. And you are immediately asked to prove something, that angle A is congruent to DCE. Okay, so we have statement and reasons, and the first statement will be angle A is congruent to angle ACB. Angle A is congruent to angle ACB. Or as it's written below, angle ACB is congruent to angle A. The reason, of course, we were given this information. Okay, so ACB. ACB. It's that angle. Is congruent to angle A. Okay? Now, we want to show that DCE, DCE, this angle is congruent to A. But we know how many slashes to put there. 1, because it equals this angle, which equals that angle. We were told that this angle and this angle were equal. Here it is. And we know that this angle out here and this angle here, they're opposite angles. I don't care that there is this extra side that we drew. There are two lines that intersect at point C, and opposite angles are equal. And then you can say, since this angle here is equal to angle C, and angle A also equals angle C, by the transitive law, A and DCE are equal. Okay, so let's say that. Angle DCE is congruent to angle ACB. Reason? Vertical angles. Vertical angles are equal, or congruent, are congruent to one another. Okay. So, I have ACB is congruent to A, and ACB is also congruent to angle DCE. Hence, angle A and angle DCE are congruent. This is the transitive law. If one line segment is congruent to two other line segments, then these two other line segments are congruent. I said it differently earlier. I said if two line segments are congruent to a third line sorry. Line segments should be replaced with angles. Sorry. If two angles are congruent to a common third angle, then these two angles are congruent. If one angle is congruent to two other angles, then these two other angles are congruent. It's a transitive property. That proof is now done. How about we have a picture like such? You have A, B, C, D, E, F, and say G. And we have angle 1, angle 2, angle 3, angle 4, angle 5. And out of order, we'll call that angle 6. Between 1 and 2 should not have been 6. Okay, and we are given the following information. We are given that GD bisects some other line segment. CBE. That's what we are given. And we want to prove that angle 1 and angle 2 are in fact congruent. Okay, so GD is this line right here. And it bisects angle CBE. Bisects that angle. That is angle 2 and angle 3 are equal. Angle 2 and angle 3 are equal. But if you just look at this portion, if you just look at this line and that line, you would notice that angle 1 and angle 3 are equal. So we know 2 and 3 are equal. 2 is equal to 3. And we know that 1 is congruent to 2. So 2 is congruent to both 1 and 3. Is there? Oh. Sorry. We don't know this yet. I'm sorry. We know that 1 and 3 are congruent because the opposites. And we know that 1 and 2 are congruent. They were given. So if 1 is congruent to 3 and 1 is congruent to 2 as well, well then yeah, 1 is congruent to 2. Because 1 is congruent. You know, why am I not saying this right? See, I'm looking at this and I'm thinking that's given. Looking at the picture, we know since they're opposite angles, 1 and 3 are congruent. And we also know that this angle was cut in half along from GD. That is, we also know that angle 2 and angle 3 are congruent. So angle 1 and 2 are both congruent to a common third angle. Therefore, we know that angle 1 and angle 2 are congruent, which is what we're asked to prove. Okay, but let's write it up nice and neatly. Statement, reasons. Number 1 is the given. Namely, GD bisects CBE. Okay, so number 2, angle based on statement 1. Angle 2 and angle 3 are equal because a bisector divides the angle into 2 equal parts. a bisector splits an angle into two equal parts. So angle 2 and angle 3 are equal. Okay. Now we're on to statement number 3. Statement number 3 is angle 1 and angle 3 are congruent. The reason is vertical angles are congruent. Okay, so looking at statement 2 and statement 3, we have two angles, namely 2 and 1, that are congruent to angle 3. So that's where we have it. Angle 1 is congruent to angle 2. If two angles are congruent to a third angle, then they are congruent to one another. If two angles are congruent to a third angle, then they are congruent to one another. That finishes that problem. In fact, that finishes the section. Good luck with it.